Hello, welcome to the Construction Record Podcast. I'm digital media editor Warren Frey, and with me I have today.
Good morning. My name is Ian Pilkington, and I'm the Chief Engineer for the British Columbia Ministry of Transportation and Infrastructure.
And we're going to talk about both in the short term and the long term, the effect of floods and climate change generally on infrastructure. And so we'll start with, obviously everybody knows about the massive floods we had last year and how much damage they did, cutting off pretty much every highway into Vancouver, for instance, but other damage besides that. What was the immediate response, and what would be like, obviously you've got to respond immediately, but what's the difference between, say, let's say a planned out repair of a highway and the fact that this damage happens everywhere all at once? What do you have to change to mitigate that?
Yeah, so it definitely was an emergency event, and we've had, in this province, being a very mountainous place, we do have events of this nature, but nothing to this magnitude, and definitely nothing that took out all of our routes at the same time. So the one thing we did is, one thing in our ministry, we are good at emergency response, although this was at a different scale, but we're set up. Our maintenance contractors, all of our highway maintenance in our province are done through our maintenance contractors, and our maintenance contractors have the ability to, part of their contracts is doing emergency response, and also part of their contracts, we've designed it so that they can also access and hire other pieces of equipment as needed, depending on the size of the response. So that was our immediate thing right off the bat for Highway 3, Highway 5, Highway 1, and up on 99. Each of the maintenance contractors in that service area started putting the call out to whatever construction equipment and people were around, and away they went. So we were very fortunate in this province. Everyone just jumped right in, started offering up equipment, especially, fortunately, there is a lot of construction going on in this province. And so a lot of them dropped what they were doing and came to our aid. So we were very fortunate that way. And that was what we did right off the bat. The big concern right off the bat was trying to reestablish the transportation corridors. That was our number one priority for sure.
Okay, and beyond the flooding itself, we had fires earlier in the year, and I was talking to some other experts who said that the fires actually contributed to the flooding because it softened the ground with certain areas, and that increased landslides. And so I guess at a more holistic level, because we obviously know climate change is real, and the government of BC has plans in place to mitigate climate change and lower emissions and everything else. What in terms of infrastructure and climate change are we doing sort of in longer term to address the fact that we're going to have events like this and they're going to be probably worse?
Yeah, and so what we've done in our ministry, and so fortunately my predecessor, the previous chief engineer, Dirk Nyland, he recognized this about 13 years ago when the term climate change was really starting to be talked about at an international level, and he recognized that there'd be concerns about how it's going to affect our infrastructure. So we actually started looking at it back then, about 12, 13 years ago. And at that time, Engineers Canada with the National Resource, NRCan, National Resource Council Canada, had done up what they called a protocol where it would you would take this climate projections that the international scientific community had already developed, and you could apply it to a piece of infrastructure. And they decided that it could be applied to a piece of highway, to a water system, a hospital, a school, whatever the case may be, to see how climate would actually, the future climate would impact your infrastructure. And they were going around and wanted people to test out this protocol they designed. So my predecessor jumped on it right at that time. We actually analyzed a few sections of highway, and one of them was the Coquihalla Highway, the western section, basically from Hope right up to the summit, the part that was impacted. And we also looked at a few other areas, recognizing we're quite geographically diverse. So up in Highway 16, up in Highway 20, out to Bella Coola, places like that. And from that, we started to figure out, and we that protocol did actually predict some of these. The biggest concern we did have was high intensity rainfall events, much like what we ended up seeing. So from that, we started looking at how we would change how we would do designs. We actually now, from that, created an internal policy that says for any designers, either our internal engineers or external consultants, any design work they're doing on our highway infrastructure, whether it's a brand new design or a rehabilitation or even an emergency repair, you must take into account the effects of future climate change. So that's an actual policy we have in place. Now, recognizing for engineers, it's one thing to say a statement like that. The engineers come back and go, okay, how do I do that? This is kind of a new thing. So we worked with our engineers in BC are regulated by a group called Engineers and Geoscientists BC. They're the ones that give the professional engineering designation to our engineers. We work with that group to help create a guideline for engineering groups. So there is, and it's available on the web. It's under EGBC. It's called Developing Climate Change Resilient Designs for Highway Infrastructure in British Columbia. And it's a guideline to help them figure out how to design as they're doing designs for us. The other thing that this protocol we did figure out is, one thing we wanted to figure out is how we design things. There's something have to change, the way we do our formulas, the methodology, things like that. What we learned is that the methodology is still sound. A lot of the engineering formulas and things that we use that have been around for some of them for hundreds of years are still sound ways to design things. But the biggest change we found was the inputs. And particularly when it comes to things like hydraulics. So when we're designing our bridges or sizes of culverts or drainage appliances, we always rely on things like 100-year flood levels or 200-year flood levels. But those flood levels or those flows were always based on historical data. And now we recognize that historical data, we can't rely on that anymore. We have to look at future data. We have to look at these climate data that these scientists were looking at. And so around this 12, 13 years ago, we were fortunate that out at UVic, there's a group called the Pacific Climate Impact Consortium, PCIC. And they started taking this data that was being designed or being created internationally, and it was at a fairly large scale. It was on like 100-kilometer size grids, and they were bringing it down to like 1-kilometer size grids within British Columbia itself to figure out, well, how does this future climate predictions actually impact us on the ground here in BC? And they were going around trying to find out from people like us or municipalities, what kind of data do we need? And so we started working with them, and we've been working with them for the past 10 years, where they're actually developing future flows on the various creeks that are around in British Columbia, and figuring out what kind of high intensity rainfall events and things we'll get, so we can now use those new inputs into these design formulas that we still use. So that's what we're doing as we plan for the future. Anything we build, basically either rebuilding or building new, has to take into account climate change.
You mentioned, and engineers have to actually deal with the practicalities of this thing, and sort of on a boots in the ground level, are there different materials you have to use? Because you have to make these things more resilient. At the same time, I would assume there's some materials you can't use because they're not climate friendly, or you can use less of.
Yeah, so a lot of it, and especially like we said, the biggest thing we've found is the hydraulic side of things, where we have to design for hydraulics. So things that might be like where a certain size diameter culvert would have been used under a road now gets upsized. So fortunately for that, it's the materials are still good, just they have to size appropriately, or drainage ditches and things of that nature now might be designed larger. One of the things that really changes in the material side of things, and we saw this on the Coquihalla, is when we're armoring riverbanks, we use what's called riprap, which is basically large boulder size rock, and we size it based on the water flows. A lot of that is getting bumped up to larger sizes. There are various new products coming out, various geosynthetics and things of that nature that you can try and use for armoring and erosion control and things like that. So we're going to be looking into more of those type of things. But a lot of again, the construction materials are still the same. It's just more how we're using them. So culverts are getting bigger, or bridges are now longer and maybe also higher. So things of that nature. So still conventional materials, just the sizing of it and placement of it is what's really changing.
Okay. And how do other factors, like besides the immediate floods and climate change, there's COVID, which sounds like, yes, you have to social distance, but also there's going to be more trucks, which means heavier stuff on bridges, delivering more stuff. There's going to be, it'll just shift everyone's priorities. So how do you even predict for that going forward with design?
Yeah, well, definitely when it comes to things like COVID, and we're definitely seeing a lot of, and we notice out with the transport trucks they're running up and down on our various highways, we do a lot. We do have planning engineers, and we try and figure out and plan for that. The way we plan for those kind of things is we basically look at all those trucks as axles on the road. So we start looking at the GVW of the trucks, the number of trucks that are traveling, and we turn that into an equivalent single axle load or an easel, and then that's how we'll design for pavement structures or for bridges. So as traffic increases, we can plan for that. We either design. Fortunately, the way it's been working is even though there's more trucks, the weights haven't changed or increased too much, so we can design the bridges to handle that. And then basically after that, we monitor. So we always, all of our bridges get inspected once a year by our bridge area managers. So we just keep an eye on things for any wear, fatigue. But the bridges are designed to handle the loads that these trucks are running, even if there are more of them. And then the next thing is that we need to expand highways, four laning, and things of that nature. So that those things we can all design into. We're kind of fortunate on the construction side with COVID. We were very fortunate in the highways world, at least highway construction. Construction never stopped. It did stop for things like vertical infrastructure, like buildings, and because you're working in confined spaces. But fortunately, in the roadworks area, lots of the people are in individual excavators. You're out in the open areas, so we were able to meet all of the health protocols and still keep building things. So fortunately, that industry wasn't too affected by COVID. I mean, there were certain things like transporting people around. You had to use more vehicles because you couldn't have as many people in a crew cab and things like that. But that part still worked pretty good. But you're right. We'll have to watch now. Goods movement is going to be a big thing. That's the biggest thing we noticed in this big event when we lost all of our highway network. Suddenly, goods movement in and out of Vancouver is critical, especially both railways going down at the same time. Things like that, we'll have to make sure we're building enough resilience into our infrastructure.
Highways are obviously key, but also bridges are key and also much more complicated. And plus, there's a lot of older bridges, and although you can probably correct me on this, in the province that are being replaced anyway. So how did you address building a bridge back at an accelerated pace that you had to, given the floods?
Yeah, so that was definitely a challenge, especially for the Coquihalla. As many of you know now, we were able to get the Coquihalla open basically in a month, which was it's an amazing engineering feat, actually. When you saw the damage up there and our original predictions, we thought this would take months. But one thing, we were doing it in a phased approach. So what we did is immediate after the floods, the big, of course, critical thing was ensuring the safety of all the people. So we went out, closed many of our highways, and then slowly opened them as they were deemed safe, as water receded and we saw slopes stabilize. Then our next big thing is trying to get these corridors back open. So up on the Coquihalla, so that we did get it open after a month, but the Coquihalla right now is not the Coquihalla of old. It isn't the 120 kilometer multi-lane highway. There's big sections that are two-way traffic, like single lanes going each direction. Of the bridge structures, what we found in many of the bridge structures, the main parts, the main kind of center, so a typical bridge has multiple spans, so it has piers and then it has abutments at the shoreline. The abutments are the parts that actually got eroded away, but the main piers survived and are still standing. So we put in basically temporary structures to bridge over from land over onto the main bridge that still existed, and both ends have temporary structures in place. So right now, basically, we used a lot of the stuff that the military use, which are called Bailey bridges or aqua bridges. We put many of those type things into bridge across. Of course, the trucks, as they go up to them, have to slow down because they're not the big, wide, typical sized bridge structures. So they're in place, and now traffic can still flow on the Coke, but it's definitely not. Right now, we're restricting it to commercial vehicles, mainly because there's a lot of commercial vehicles that are running up and down there, and we don't want to mix them up with just passenger vehicle traffic. But it is not the usual Coke. So at least we got the Coke open, and now we're going into the next phase where the permanent repairs will happen, and that'll take much longer, of course. Now there's actual design work that's going to be done, figure out how to replace those temporary Aqua and Bailey bridges with the permanent bridge structures, and that's where the climate change part's going to come in, where our designers will have to consider climate change. Most likely, what will happen is those bridge spans, the original lengths they were, will probably get a little bit longer. They'll have to be placed on piles to make sure there's erosion resistance and things like that. So that's the next phase we're just entering into now that we got the Coke open.
And finally, there's been a push to replace aging infrastructure like the George Massey Tunnel and other big projects. Has this accelerated? Has these series of events accelerated that? Did that tie into the plans that are already in place?
Yeah, so far it hasn't accelerated too many things because we always have a rolling 10-year plan for all of our infrastructure. And like you say, we were always inspecting all of our bridge structures and tunnels and things of that nature, and we have it on a rehabilitation program. So we've got a set amount of budget that every year we're spending, on average, we spend about $300 million per year on rehabilitation. And so we've got all of our bridges in a queue as we're watching them, and certain bridges we can do rehabilitation things on it. So like a bridge redecking or replace a few stringers, and that'll extend the life. Some of them we figured out, like George Massey, it's hit the end of its life. It's due for replacement. So those things are all still in place. And as each of them gets replaced, they do get replaced, then the new replacement will account for climate change. But you're right. I think the next thing now is we have to look at, are we going to start proactively replacing things early? So most things that we replace it because it's hit the end of its design life. Things like on the Coquihalla, and we've had that question before, they said, well, these bridges got damaged. Would you have replaced something or done something differently? And the thing with the Coquihalla, it's actually the Coquihalla is one of our youngest pieces of infrastructure. It's only 35 years old. So from a design life point of view, it's only a third of its way through its life. So if we're going to start now actually proactively replacing things that haven't hit the end of their life from a materials point of view, but maybe need to be upgraded due to climate change, that's kind of a new thing we're still wrapping our head around. Do we have to start doing that, recognizing we also have all this aging infrastructure that needs to be replaced? So trying to balance those things, that's something that we're still trying to figure out. We're still it's kind of a new thing for us, but definitely the replacing of aging infrastructure, we've got that already in a 10-year plan, a rolling 10-year plan, and as each of them gets replaced, it gets replaced with climate change being thought of in their design.
Okay, Ian, thank you very much for joining us on the Construction Record.
Well, you're most welcome. Thank you for having me.